Welcome to the debate.
Great to be here.
Today we are tackling a question that feels intensely personal, but it's grounded in the deepest, most ancient mechanics of our biology. It's the kind of thing that keeps people up at 3 a.m., just staring at the ceiling. Why is the human brain so notoriously bad at letting go? I mean, we've all felt it. The way a heartbreak or a professional failure sticks to us like Velcro, while the good stuff, the joys and successes, just seem to slide right off like Teflon.
It really is the universal human frustration, isn't it? We want to move on, we consciously decide to move on, we tell everyone we've moved on, and yet our neural architecture seems to have other plans. You can feel hijacked by a memory that's 5, 10, sometimes 20 years old.
Exactly. And so the central tension for us today is this. Is this stickiness, this absolute refusal of the brain to just delete the file, a brilliant evolutionary feature that we should respect, or is it a glitch, a kind of effective inertia that we're actually meant to overcome? I'll be honest, I find myself firmly in the first camp. I believe what we call baggage is actually a sophisticated, biologically ingrained survival mechanism. The brain's a prediction machine. Its job is to keep you alive, not necessarily to keep you happy. Clinging to the past is how it prevents future danger.
I see why you'd think that, and it's certainly the dominant story in evolutionary psychology, this idea that every quirk of the mind has to have a survival purpose. But let me offer a different perspective. I think we often mistake a biological accident for a biological purpose. Just because a feeling persists doesn't mean it's doing useful work for us. I'm going to argue that this stickiness is often maladaptive, a failure of regulation, or what some researchers call effective inertia. And I think more importantly, the neuroscience of reconsolidation suggests we are actually designed with the capacity to update and even erase these traces. If we could just stop clinging to this philosophical illusion of the self that seems to need suffering to feel real.
Okay, that's a bold claim. And I do want to get to the illusion of self later because that's a heavy concept. But let's start with the foundation. To understand why we hold on, we have to look at what the brain is actually doing. We tend to think of the brain as reactive. Something happens and we react. But as neuroscientists like Lisa Feldman, Barrett, and others have really revolutionized our understanding of, the brain is primarily concerned with body budgeting, or allostasis.
Body budgeting makes the brain sound like a little accountant in a back room. It's a bit more visceral than that, isn't it?
It is, but the accounting metaphor, it actually holds up because it's about resources. It's about managing glucose, salt, water, oxygen. And in that budget, predicting a threat is infinitely more valuable than predicting a treat. Let's do a thought experiment. Imagine two of our ancestors walking through the Pleistocene forest. Ancestor A hears a rustle in the leaves, assumes it's the wind, and just keeps walking. Ancestor B hears a rustle, assumes it's a tiger, and sprints for the nearest tree.
The classic paranoia versus peace scenario.
Right. Now, if it was a tiger, Ancestor A is dead. He doesn't pass on his genes. Ancestor B, well, if it was a tiger, he survives. If it was just the wind, he wasted a few calories running up a tree. That's a very low cost for survival. We are the children of Ancestor B. We are literally the offspring of the panic attacks. Evolution doesn't care if you're anxious. It just cares if you survive long enough to reproduce. So when your brain holds on to a negative memory, it is essentially saying, I am not going to let you forget where the tiger lives.
I grant you the evolutionary logic of the bear in the forest. I mean, if you forget the bear, you die. I get it. But here's where I kind of have to step off the train. You're describing a system that works perfectly for, physical predators. But we are dealing with these complex social emotions. The problem is affective inertia. This is a concept researchers are looking at very closely now. It's the resistance of an emotional state to change. When we look at people with depression or high anxiety, they have high inertia. The emotion just hangs around long after the stimulus is gone.
But isn't that just the system working overtime? Better safe than sorry?
No, I think that's a dangerous oversimplification. There's a real danger in misattributing temporal persistence to adaptive functioning. Just because a depression lasts a long time doesn't mean it's protecting you. It often indicates a lack of regulatory flexibility. The brain gets stuck in a limbic loop. We have to distinguish between emotional flexibility, the ability to shift states, and the Velcro effect you mentioned. High inertia means the system is rigid. It's not predicting a bear anymore, it's hallucinating a bear because it has lost the ability to update its own data.
I think you're underestimating the structural commitment the brain makes to these memories, though. It's not just a habit or a loop that you can think your way out of. Let's get into the biological architecture, because this is where the feature argument really solidifies. We know the amygdala acts almost like a mixing board in a recording studio.
A mixing board?
Yeah. Imagine a mixing board with a fader for every memory. Normally, the faders are set to a comfortable 5. You remember what you had for lunch, but it's quiet. But when you have an event with high emotional arousal, fear, shock, pain, the brain floods the system with norepinephrine. This chemical doesn't just make you feel jittery, it acts like a hand that jams that fader all the way up to 10, and then it breaks the knob off.
That is a terrifying image.
It's effective, though. The norepinephrine signals the hippocampus, this track is important, do not delete it, burn it on to the hard drive permanently. This is the stress acceleration hypothesis. Research shows that early life adversity actually changes the connectivity between the amygdala and the prefrontal cortex. It essentially accelerates the maturation of these fear circuits. The brain decides, okay, the world is dangerous, so I'm going to build a superhighway for threat detection and a dirt road for relaxation. That is not a malfunction. That is an adaptation to a hostile environment.
See, that is where a full determinant's view is flawed. You're describing the brain as if it pours concrete. Once the highway is built, that's it. But newer research on entangled representations really challenges this. We used to think the amygdala was the emotion center, and the prefrontal cortex was the thinking center, and they just fought for control. But we now know that single neurons in these regions encode both emotion and cognition simultaneously.
Meaning what exactly?
Meaning the memory isn't just a file stored in a vault that you can't touch. It's a dynamic reconstruction. And we have gatekeepers. Take the thalamic reticular nucleus. It acts like a bouncer at a club. It decides what sensory information gets into your conscious awareness. When we are anxious, the prefrontal cortex tells the bouncer, only let the bad guys in. Look for threats. So you scan for the bear. But that is a policy decision by the brain, not a structural wall. We can change the bouncer's orders.
You say we can change the orders, but the brain is biased against that change. You're touching on the predictive brain again. The brain hates surprise. Surprise is metabolically expensive and, potentially deadly. If I assume the world is safe and I get hurt, that's a massive prediction error. If I assume the world is dangerous and I'm wrong, I'm just safe. The brain is biased toward the false positive. What you call baggage, that lingering mistrust after a betrayal, for instance, is the brain using past data to minimize the surprise of a future betrayal. It's a highly effective security system.
Effective for survival, perhaps, but catastrophic for thriving. If you live your life in a defensive crouch, you never see the sky. And this brings me to my main counterpoint, and frankly, the most exciting part of this whole science, the mechanism of change. You talk as if these memories are set in stone once they're consolidated, but the science of reconsolidation just blows that idea out of the water.
I was waiting for this. Reconsolidation is fascinating, but you have to be careful not to oversell it.
I don't think I am. Let's look at the foundational work by Kareem Nader with rats, because it really did shock the neuroscience community. The old dogma was that you have short-term memory, which is like wet clay, and long-term memory, which is like baked stone. Once it's baked, you can't change it. But Nader asked this crazy question. What if remembering something makes it wet clay again?
This is the protein synthesis study.
Exactly. So he took rats that were terrified of a specific tone. He played the tone, the rats froze, the memory was retrieved. The file was open. But then, right at that moment, he injected a drug that blocked protein synthesis. He basically prevented the brain from saving the file again. And guess what happened?
The fear was gone.
Not just suppressed, gone. The rat wasn't brave. The rat literally had no record of the fear anymore. The memory had been erased. This proves that every time you pull up a heartbreak or a failure, it enters a liable state.
It becomes fragile. It requires energy to be resaved. We aren't carved in stone. We are rewritten every single time we remember.
Okay, but we have to be precise here. In a lab, you can inject a protein blocker into a rat's amygdala. We can't do that with humans, well, not ethically. In the real world, what usually happens when people try to move on isn't reconsolidation, it's extinction learning. And there's a massive difference.
There is. And it's crucial for our listeners to understand this.
Extinction is what happens in most standard exposure therapies. You're afraid of the dog, you sit near the dog, nothing bad happens. You learn dog is safe. But you haven't erased the dog is dangerous memory. You've just created a new memory, a safety memory, that sits on top of the old one and inhibits it.
Right. It's like putting a rug over a stain on the carpet. The stain is still there. You just can't see it.
Exactly. And because the stain is still there, under stress, or with the passage of time, the rug gets pulled up. This is called spontaneous recovery. It's why someone can feel over a trauma for years, and then a smell or a sound brings it rushing back with its full force. The brain refuses to delete the original survival data. It keeps a backup copy because, again, it prioritizes the bare data over the safety data. The advocate in me says this proves the brain doesn't want you to let go.
And the dissenter in me says that's exactly why we need to aim for reconsolidation, not extinction. We don't want to cover the stain. We want to chemically clean it. And we can do that behaviorally. The key is the prediction error.
The element of surprise.
Yes. For a memory to be unlocked and rewritten, the brain has to be surprised. There has to be a mismatch between what you expect and what happens. If you expect the dog to bite and it doesn't, that's a small error. But if you expect the dog to bite and it actually licks your hand, and you feel this surge of unexpected safety, that massive mismatch opens the window. The problem is, most of us avoid the prediction error. We avoid the places that hurt. We avoid the relationships that might trigger us. And by avoiding the trigger, we never give the brain the chance to see that the bear isn't there. We just sit in the car and resave the map of the dangerous forest over and over again.
I agree with the mechanism, but I think the barrier is higher than you're admitting. In real life, prediction errors are messy. It's easy to shock a rat and then not shock it. It's much harder to replicate the complex social pain of a divorce and then prove definitively to your limbic system that it's safe now. The brain's threshold for overriding a danger signal is incredibly high, and I would argue that high threshold is there for a reason.
I think the barrier isn't just a biological threshold. It's philosophical. It's identity-based. We struggle to let go because we confuse the memory with who we are. We build a narrative self.
You're pivoting to philosophy, but I want to keep this grounded. How does narrative self show up on an fMRI scan?
It shows up in the default mode network. This is the brain network that lights up when you're daydreaming, thinking about the past, or thinking about yourself. It stitches your memories into a biography. I am the person who was betrayed. I am the person who failed at that startup. And the default mode network is heavily interconnected with these emotional centers. So if you use reconsolidation to remove the sting of that failure, the default mode network kind of panics.
Why?
Because it loses a load-bearing wall of your identity. It says, wait, if I'm not the victim of that event, then who am I? We hold on to the pain because it provides structural integrity to the ego. We prefer the certainty of our suffering to the uncertainty of being someone new.
I see that. It's a powerful point. But I would argue that even that identity clinging has a survival basis. We are social animals. In the Pleistocene, social connection was the currency of survival. If you were rejected by the tribe, you died, period. So social pain is encoded in the exact same neural hardware as physical pain. The interior cingulate cortex lights up for a broken leg and a broken heart.
But that's the mismatch, isn't it? We are running Stone Age software in a modern world. Being unfriended on social media or embarrassed in a meeting is not a death sentence. But your body reacts as if you are being exiled to the tundra to freeze to death. That is maladaptive. That is why we need to leverage our cognitive capacity to override this so-called security system.
But can you really override it just by knowing that? I mean, the internal working models of attachment are formed in infancy. If your early environment taught your amygdala that people are unreliable, that's a deep implicit prediction. It's below the level of conscious thought. As Lisa Feldman Barrett points out, the best thing for your nervous system is another human. The worst thing is also another human. We are biologically regulated by others. Holding on to the memory of a bad relationship isn't just a narrative choice, it's the nervous system trying to protect its own regulation. It's trying to keep the budget balanced by avoiding bad investments.
It is, but this is where I return to the idea of agency. We are not just our amygdala. We have a prefrontal cortex that can exert top-down regulation. We see in therapy and in the neuroscience of affective labeling that simply putting feelings into words, engaging the right ventrolateral prefrontal cortex, it dampens amygdala activity. It literally turns down the fader. The struggle is real, yes, but the inevitability of it is a story we tell ourselves. We are capable of what researchers call regulatory flexibility, shifting our strategy to match the context. If the tiger is gone, we need to learn to turn off the alarm.
I'm just not convinced we can simply turn it off. I think we can learn to manage the volume, but that alarm system is autonomous for a very good reason. And I worry that labeling this persistence as maladaptive or inertia pathologizes a healthy survival instinct. If someone is grieving for a year, are they stuck or are they processing a massive recalculation of their entire world model? The brain takes time to update its predictions because the cost of getting it wrong is so high.
But there's a difference between processing and ruminating. Processing moves toward integration. Rumination is a broken record. And the neuroscience shows that rumination, that repetitive replaying, actually strengthens the synaptic connections of the negative memory. It's like carving a groove in the mud deeper and deeper. At some point, the survival mechanism becomes the threat itself. Chronic stress, high cortisol, the wear and tear of allostasis, this protection can kill us faster than the imaginary bear.
That is a fair point. The allostatic load, the wear and tear on the body from constant stress, that's real. But I would argue that the way out isn't to fight the biology, but to work with it. We need to respect that the brain requires overwhelming evidence of safety to override a danger signal. It's not about deciding to let go. It's about providing the nervous system with new, repetitive data that contradicts the old prediction.
We agree there. It's about the prediction error. But I would emphasize that we have to actively seek that error. We have to be willing to be wrong about our trauma. We have to step into the forest again and see that the bear isn't there. If we just stay in the car, which is what your security system wants us to do, we never trigger the reconsolidation that allows us to heal.
And that is the crux of the tension, isn't it? The brain wants to keep you in the car because the car is safe. You want to go into the forest because that's where life is.
Exactly. And to go into the forest, you have to risk the surprise that the brain hates so much. You have to risk the possibility that you might get hurt again in order to prove to your amygdala that you might not.
So where does this leave us? I am still maintaining that the struggle to let go is the sign of a high-functioning security system. Your brain is doing exactly what it evolved to do, prioritizing the memory of pain to ensure you don't repeat the mistake. It's annoying, it's painful, but it is, at its core, an act of self-preservation.
And I maintain that while the system was designed for survival, we are living in a context that requires psychological survival, which means flexibility. We have the neurobiological capacity for change, neuroplasticity, reconsolidation, extinction, but we underutilize it because we get attached to our narratives. We are keeping ghosts alive in a house that is no longer in danger.
Perhaps the synthesis here is that letting go it's a misnomer. It's not about deleting the file. It's not about forgetting the bear.
No, it's about updating the prediction. It's about integration rather than erasure. We want to move from pathological rumination, where the memory controls us, to adaptive prediction, where the memory informs us but doesn't paralyze us.
Agreed. It is about convincing the amygdala that the war is over. And that takes more than just a thought. It takes experience.
It takes the courage to create a prediction error.
So, to our listeners, we leave you with this. Is the memory you are holding on to acting as a necessary protector, a scout watching the perimeter for threats? Or has it become a ghost, haunting a house that is, for all intents and purposes, safe?
Are you avoiding the forest because there is a bear, or because you just remember the fear of the bear?
Thank you for listening to The Debate.